Can you imagine looking at the sun, or relying on dripping water to tell the time? Well, the great civilizations in the Middle East and North Africa first defined time by doing so. While the early sun clocks were helpful during the day, it was the first water clocks that told the time regardless of the weather or the setting of the sun, or where you were on Earth relative to the sun's position. In their simplest form, water clocks were among the most commonly used timekeepers. Knowing the time of day was essential in the practice of Islam, for daily prayers and for making the most of the day with time to spare for good deeds. The first Islamic water clocks were based on the design of the Egyptian clepsydra from around 1500 BCE. This was a simple vase marked off in time increments which recorded the flow of water out of a spout. One of the first examples of an Islamic water clock was the public clock for the city of Maya Farikin, designed and constructed by the engineer Nasir al-Dawla of Diyarbakir in 1012 CE. Muslim engineers borrowed from and improved on water clock designs made by Greek and Indian engineers. They were the first to introduce segmental gears and sinking floats into water pumps. By combining and developing these new discoveries and devices, Islamic engineers built the finest water clocks in the world at the time. These water clocks, however, were more than functional devices. They were examples of fine technology, beautiful, awe-inspiring machines that celebrated achievements in engineering, the universal nature of Islam, and the skill of the engineers themselves. The most notable engineer of clocks was Al-Fadzri, a Muslim engineer from 12th century Baghdad. He built a large number of mechanical devices that revolutionized engineering, giving birth to the concept of automated machines or robots. Al-Fadzri recorded 10 of his water and candle clocks in his book, The Book of Knowledge of Ingenious Mechanical Devices. One of the most sophisticated water-powered astronomical clocks was Al-Fadzri's castle clock, considered to be the earliest example of a programmable analog computer. Probably his most famous clock was the elephant water clock, a striking piece of fine technology. This eclectic work comprised of a large wooden carving of an Indian elephant supporting a tower holding two pivoting Chinese serpents, with an Egyptian phoenix on top. It also incorporated Phoenician water technology, 3 Arabian figures, and Persian carpets. A black and silver disc at the top of the clock showed the number of hours since sunrise, while the number of minutes into the hour was shown by a scribe's pen. Inside the belly of the carved elephant was a mechanism consisting of a perforated bowl inside a tank that governed the timings and workings of the clock. A small hole in the floating bowl regulated the speed at which it sank. As it sank, every half an hour, it tugged at a system of pulleys to initiate the next half-hour cycle of the clock. When the bowl submerged completely, it quickly tilted, sank, and triggered the next sequence of events. At the top of the clock, a channel of balls tilted so that a stopper was lifted to allow one ball to fall from the falcon's beak into the mouth of a serpent, which pivoted downwards. The ball was then tipped into a vase that triggered the mahout's mallet, hitting a cymbal which signified that half an hour had passed. As the ball collected in a trough, the float began to submerge again, and the whole process started all over, with subtle adjustments for the second half of the hour. The majestic elephant water clock was a bold statement of status, achievement, and technology, in which Al-Fadzri incorporated some of the first examples of robotics into a complex machine.